Hey, what's up, buddies? This is Tony with Data Driven MQB. If you haven't yet, check out www.datadrivenmqb.com and like it on Facebook. This video is to go over the MK8 PCV retrofits with some feedback I've been collecting from those that have done it. It hasn't been 100% successful, and I didn't expect that to be so, but there might be some trends that we can look at and now make a more informed decision as to if it might be right for you. Due to some of the cars having issues, I wanted to take a closer look at the two main MK7 PCV valve designs for a better understanding of their differences, since Volkswagen has not superseded the 15 to 18 GTIs to use the same as the 19 Plus, for instance. We're also going to take a look at how important the Venturi is to maintaining crankcase vacuum and how this can affect the diaphragm, plus why it is probably the key attribute that keeps the MK8 GTIs and Rs from smoking on track. Finally, we'll go over some updated recommendations moving forward. So here are the overall results I've collected from people so far. We got 7 who retrofitted and did not have problems prior and still no problems with the MK8 valve. We got 6 people who had problems prior and it was fixed. And we got 6 people who had problems prior and it was not fixed. We got a pretty good mix of different turbos. We got a pretty good mix of different model years. It is worth noting that other than one guy on here, everybody was a basic retrofit. Mine, I've done it in both basic and with the with a Venturi retrofit, so that's just one thing to be aware of. So let's take a look at the people that had problems first, and we'll go from there. So what jumps out to me immediately when looking at these results is that every one of the cars is a 2015 or 2016 model year, and every one of them has had to be on track or autocrossed in order to induce the problem. GTI Jake, in his IS38 2015 GTI, said that he had one puff of smoke from his BL MK7 valve ever, and it was not as bad as with the MK8 valve in the basic retrofit form like everyone else here. He did also initially have it installed with the Vargas turbo oil cap breather, which we're unsure of possible side effects, since any venting to atmosphere in the cam cover could have unknown consequences. His APR turbo inlet pipe has also been rewelded due to the fitting breaking off originally. So I still haven't done any testing on the effects of the turbo inlet pipes on these cars yet, and that's something that really needs to happen because almost everybody has aftermarket stuff on their cars. Mr. Matto, in his IS20 2015 GTI, has tried a bunch of different PCVs, and for him the AH or AP valve were best when used in combination with a BMS catch can, and he could still induce a bit of smoke under only the absolute hardest circumstances when autocrossing. Monkey MD, he installed an iSweep oil pan at about the same time as the MK8 valve. They market it as baffled, but the baffles are honestly kind of a joke. He reinstalled his MK7 PCV, I believe it was the BL revision, and he was able to induce the exact same kind of smoke even on the street in his IS38 1.8 Golf. Let's see, one other person I actually talked to directly. There wasn't anything particularly strange about Joe Clifton or Ben H. Yakev, he did say he actually has the stuff on the way to do the full retrofit to test that out, so I'll be looking for his results very eagerly come early next year. Here's a really quick snapshot of these 6 cars that had issues, and the turbo inlet pipe air filter combinations that they're running, a little bit of their miscellaneous comments and stuff there, and turbos and stuff. We'll be coming back to the turbo inlet pipe and air filter intake stuff just in a little bit. Moving on, taking a look at the people that had problems and the MK8 valve fixed it. Again, we've got a pretty good mix of turbos. We've got a pretty good mix of model years. We do have a couple of the 2015s in here. Those were street driven. a few others. This guy Mosquito, he's been behind the Mark 8 stuff for quite a while, and I've spoken with him quite a bit. He does not autocross or track the car or anything. Me and Skrullik do that. I believe IT Guy is getting ready to retrofit the full Venturi, though he has not had any issues yet. His engine is a built engine, and he has not had any problems on the street yet. I believe he has a 2015 or 16 GTI. So, yeah. So looking at the turbo inlet pipe and stuff, you can see all of that here. Again, it's not, I'm not necessarily saying that stuff has to be stock, but there might be some weird combination of parts that may or may not be acceptable, and it may depend on turbo and stuff as well. If you're moving more air, you can probably free up restriction a little bit more and maintain the same pressure differential across the diaphragm inside the PCV. Again, more on that later. But we've got this J Reyes. He has a Garrett 2260, I believe, turbo. Actually just found out that he lives very nearby me, so hoping to get some more data directly off of his car very soon. Got another guy on a 3076R. This is a pretty silly IS38 right here. Again, this one is street driven. IT Guy, he's got a big turbo as well, so street big turbo seems to be pretty good application for it, at least. So now we're looking at the people who did not have issues before, and they still do not have issues. Again, we've got a pretty good mix of turbos. We've got a pretty good mix of model years, with the notable thing to observe that there's only one 2015 and no 2016s. You know, it's all of the newer stuff, a bunch of 17s in particular as well. So we'll take a quick look at those a bit closer. So looking at their turbo inlet pipes and everything here and the turbos, you can see the one guy who was tracking 31 Sam, he has a stock turbo inlet pipe and air intake and everything. Everyone else, there's, you know, a few big turbos here. One guy noticed greatly reduced knock. That's a big turbo car. So yeah. So due to the 2015 and 2016 cars seemingly showing up a little bit more, I wanted to take a closer look at the PCV valves that originally came on these cars. One distinct difference between the 15 to 18 GTIs and the 19 Plus is the PCV valve they're spec'd for. 2015s originally came with this AH valve right here, which has this weird little protrusion circled in yellow. I used a hot knife to cut open the AH, the BL, the BK PCVs to inspect their internal differences. I have not cut open the Mark 8 valve yet. I'm going to be ordering another one, though, to do that specifically. The main finding here is that the 2015 and 2016 AH PCV valve assembly pulls vacuum primarily on the cam cradle, not the blow-by port as originally outlined in the Volkswagen SSP. Did want to give a big thanks to IT Guy for donating the AH and BL PCVs. Coming back to this whole diagram from the original video, just want to very quickly revisit the oil and blow-by path. It's important to understand that according to the Volkswagen SSP, previously referenced, the only place that blow-by is being pulled from is this red path right here. This applies to the BL and the BK valves, and functionally the Mark 8 valve does the same thing as well. Vacuum is pulled from this blue path when the engine is in vacuum, you know, low load or no load, and there's a one-way valve that closes off in here, and the turbo inlet pipe then pulls a vacuum. Once the turbo spools up, it generates a vacuum, and that is what is drawing on the air oil separator, on the top of the air oil separator here. So this here is the BL valve with the bypass valve removed. Normally sits right here. not exactly visible, but basically the oil blow-by port originates in the bottom end. It comes up the red path previously shown, and it flows under this bypass valve, assuming it is not open, and straight into the air oil separator through here. Stuff spins around. Meanwhile, vacuum is being drawn on the center of the cyclone from this piece right here. This is the top of the valve. Essentially, vacuum is being drawn through, and it's getting sucked through here and flows out. And back at this angle, air flows across the bottom of the PCV here and up to the diaphragm chamber, and then down into the center where it goes to the intake ports via the cylinder head blue path, either under no load or low load, or into the turbo inlet pipe if you're wide open throttle and the turbo is spooled essentially. So where the AH valve differs is as oil comes in through this oil blow-by passage, you'll see there's a one-way valve here. This is only going to open if the pressure is greater inside of this PCV here on the bottom side of where the one-way valve would normally be than it is in the blow-by passage, which seems weird to me considering that this blow-by port exists to vent into the air oil separator. I'm super curious to see if I can get my hands on an AP revised PCV valve to tear open and see if this one-way valve is still there or if there's anything else different about it. Moving on, this is an AH style valve here. This is the opening of inside the cam cradle where the AH valve pulls vacuum on rather than on this blow-by port like the SSP shows. This area here at the base of the valve is where that passage on the bottom leads to. You can pour a bunch of brake clean stuff down in here, and that's where it runs out of the valve. You will see, and that comes in under here, and you'll see a little sliver of daylight right there. All of the PCV valves I've seen, all of the Mark 7 PCV valves I've seen and torn down this far enough to see it, have a tiny relief right there. I suspect it's a drain to allow any oil inside of the valve to drain down, and that goes down into the yellow pathway, the air oil separator drain passage essentially. And then just for reference, for any of the Mark 7 valves, any oil that comes up past this bypass valve, it collects in this little channel along the side here. It does not just go straight over here like I had previously thought, or kind of what I thought that the diagrams looked like. There's a very small hole at the very back end of this that will allow it to drain back down into the yellow pathway from the diagram. I suspect that under hard braking and right-hand turns that enough oil can pool along this area here that the oil can run over this step between the bypass valve and the air oil separator, which leads into the main chamber of the valve, where it might get sucked up depending on what exactly is going on, if the turbo just started spooling and stuff, which coming out of a corner makes quite a lot of sense. And as you can see here, to check the BL valve for a similar passageway right here, I filled this little opening with brake clean. Long story short, this does not go anywhere. I think it's probably just a leftover opening from the manufacturing process that doesn't have a need to be sealed. This small one-way flapper right here is actually visible just inside of the turbo inlet pipe connection. It will only open when pressure in the cam cradle is lower than pressure inside of the PCV assembly. I suspect that this would only drain briefly when the crankcase has previously had a solid vacuum on it and you let off the throttle and the vacuum source goes away inside of the PCV, but there's still a tiny bit of residual vacuum in the cam cradle for just a split second. So looking at some other possible differences, I was curious about the oil pan baffle assembly. I had a friend at a local dealer run a bunch of various GTI and R VINs looking into this oil baffle difference. I was curious since all the cars that have had issues were 2015 and 16 model years. Possibly a coincidence, but I did find it interesting. ETCA calls for this 138P part number on all 2015 and 16 GTIs built prior to May 31st, 2016. GTIs built after September 5th, 2016 is when the switch over to the AP PCV occurred and came standard, and the AH was superseded and no longer available after January 1st, 2017. ETCA calls for this Q part number on all GTIs built after May 31st, 2016 through the 2021 model year. So pretty much everything 2017 model year and newer. To make things even stranger, every Golf R has this P revision baffle. So what exactly is different about the baffle? To make things short, I don't know. This is a picture of the P revision oil baffle, the early car, and all the Golf Rs. I tried looking at like a bunch of pictures of these things on eBay and stuff, and I don't see any noticeable differences by eye. I did find some more detail on how these baffles work and how it might possibly be aiding oil getting where it really should not be. This tube at the front here, this is the front of the car, this is the rear, driver's side, passenger side. This tube at the front here is where the red path in the block connects to. If you hit the brakes hard and or have a hard right-hand turn, it could potentially submerge or cover the opening on the bottom here, at which point that turns the pathway into a straw. This here is the drain port for the yellow path. So here's the red path from the opposite side. It's got a little bit of a relief cut right there. And you can also see the little one-way flapper valve on the bottom of the drain port. There's a small opening cut into it, so it will never be 100% fully blocked, but I do wonder about the quality or variability and how freely this thing might hinge open to let any blow-by oil drain. If the drain port for the yellow path fully fills up to the point that it's backing up into the PCV, this could be the root problem. I personally can't imagine how oil would force its way up the drain path anyway with such a tiny opening in the PCV air oil separator outlet. But it's worth noting that this path is blocked or nearly blocked when installing an iBed oil pan, according to one owner of it. So looking at some pictures of the Q revision on the newer stuff for everything after that May 2016 date, I don't see any visual differences. I imagine if there's anything, it could be like an overall height difference in, some of these, like maybe the height of these, maybe this flat portion sits a little bit lower in the pan or higher in the pan. I don't know. If this Q revision had happened and coincided with the 2019 model year, it would make more sense to me because we all know that the oil pump is different on the 7.5 GTIs. All the cars that call for 0W20. Some people that I spoke with had suspected that a supplier difference might have been the reason for the change, but that does not explain why both of these two part numbers are still active in ETCA. If you look up a 2015 or a 16 GTI, they will sell you a P revision. If you look up anything built after that September 2016 date split, you get the Q revision. Or if you have a Golf R, you get the P revision for all years, according to the guy who I was pestering about all of this at the dealer. And here's another little bit of a look. If you actually zoom way in on that diagram from the beginning here, you can actually see where this yellow path comes down to. And the little one-way flapper valve is inside of there. The red path is not as well detailed, unfortunately. And again, this is just something that kind of makes me really curious as to what the differences actually are. I don't see anything that is blatantly obvious as far as differences between the two oil baffles, but it's something that might be worth looking into further. So I never really talked about it much in the original video, but let's take a look at the diaphragm assembly. The concept applies to both Mark 7 and Mark 8 valves, because all that this basically is it's a simple single-stage vacuum regulator. The spring's got to be a very specific weight that pushes the diaphragm open by default. Vacuum is drawn from the center of the valve, and that comes from your turbo inlet pipe when you're at wide open throttle with the turbo spooled, or at idle or low load when the intake manifold has vacuum available. In order for the diaphragm to close, it first needs to draw a vacuum on the entire crankcase, which is generating blow-by, past the piston rings the entire time. Overcoming the blow-by so that the average pressure inside of the valve itself becomes enough to overcome the spring force. The negative pressure, more accurately, has to overcome the spring force, and it will close the valve. Now, if you have a lot of blow-by or pressure in the crankcase, and it doesn't necessarily have to be blow-by, it could be from leaking valve stem seals as well, which seems to be a slightly more common thing on these vehicles. Of course, and then there's worn rings and, the usual stuff as well that is, actual blow-by. Then it could require more vacuum to close the diaphragm fully, or at the very least, it'll take longer to close it because it won't be able to draw that vacuum, or it won't be able to draw down the pressure that's being generated a little bit faster. So if your vacuum is weak also, you have a bad connection at the turbo inlet pipe, for instance, or maybe a super high flowing air filter. There's not going to be as much of a pressure drop across the air filter, so there's going to be less vacuum generated in the turbo inlet pipe. Same thing could potentially happen. I got to measure some more stuff. I've got to do that on my own car and compare to some other stuff as well. So the main takeaway, though, is that this diaphragm operating range is 100% dependent on the ratio of crankcase pressure versus the vacuum draw that gets generated. When I was measuring crankcase pressures previously, it is important to note that it's a post-diaphragm. It's in the crankcase itself after the diaphragm has already regulated it down. So the diaphragm and the spring seem to be calibrated to maintain approximately 2 to 2.5 inches of vacuum. Now, since this is a regulator, if the vacuum source goes away, such as when you're taking off from a stop without the venturi, then the diaphragm is going to open wide because there's no longer sufficient vacuum to pull the valve closed. Now, the reality is this is likely it's going to be a much more dynamic process, even when vacuum is kept, pretty constant. Like with the venturi, the valve is going to be drawn closed once vacuum is pulled, and even with the venturi, it's going to just crack open just very slightly, and just basically just enough to let, get the blow-by through just a little tiny bit at a time. So you can imagine without the venturi that if your vacuum source is constantly coming and going, this diaphragm is going to be opening and closing large amounts constantly because the regulator is doing its job. It's responding to waves of pressure and vacuum. As a refresher, we'll take a look at a couple videos with and without venturi now. So real quick, we're just going to briefly revisit what kind of fluctuations we're seeing in the crankcase pressures between a basic retrofit of the Mark 8 valve and with a full retrofit using an 034 turbo muffler delete to the venturi routed to the turbo outlet. These videos are courtesy of Mosquito and his IS-38 Golf R. I sent him my oil cap to run these tests to have it verified on another vehicle.
This is fast acceleration from a stop.
You see how taking off from a stop, crankcase pressure drops to 0 or maybe even just a hair positive, like 1 psi or whatever. but the point is it's fluctuating. Now, with the Venturi,
acceleration from a stop.
it stays in vacuum the entire time. So it keeps it much more stable overall. By not losing your crankcase vacuum, the diaphragm isn't going to really have a need to, pop wide open to maintain crankcase vacuum. It just never loses it in the first place. So with all of that factored in, there's at least one last potential idea to try and make the MK8 PCV valve work as a basic retrofit, which will more closely mimic the AH style PCV valve. I decided to start by putting a few 1/8 inch holes in the bottom of my spare MK8 PCV. I actually pre-marked it for a few extras, but I ended up only doing 6 of them. I've had this version installed on my car now for about 3,000 miles, and I've put 10 autocross runs on it last weekend between me and my co-driver. We had no smoking, no problems, no noticeable oil burning. So I've daily driven with this valve in the basic retrofit form, though I now have it in the full retrofit form with the Venturi, and that's how it was autocrossed on, for reference. My primary worry of this modification was the cams slinging oil up and getting sucked into the engine. I don't doubt that there's some negligible amount of that going on, but it has not shown itself to be a problem on my car yet, and it hasn't shown up as knock, at least not at the autocross event. So this chamber right here is directly below the diaphragm on the air oil separator side of the valve. This means that air is being pulled through here, is regulated by the diaphragm, so it won't have any weird unintended consequences such as pulling too much vacuum on the crankcase, which might cause some issues. There's a little plate that can be removed on the other side of this, which gives pretty good access to making sure you can get any plastic shavings out of this if it's done. I do not recommend anybody try this until we've got some more thorough testing. In my opinion, if it doesn't fix one of the cars that had a confirmed issue smoking, then this is absolutely not worth doing. The whole concept behind doing this is rather than having 100% of the vacuum being drawn on the oil separator path, if it's pulling some on the cam cover, it's essentially going to act similar to if you're sucking up on a straw and you have a hole in the side of the straw, or the straw has a crack in the side of it, and you're trying to get the liquid out. If you're sucking on air, the liquid is not going to come out anywhere near, it isn't going to come up nearly as easily. So the idea of doing this is to make it a lot harder for the PCV to suck oil straight up. So I'm going to be sending this off to a friend in Florida, Mr. Matt O, to test for autocrossing, since he has had a confirmed problem with his MK8 valve not working out for him, and we'll be sure to report back probably within a few months, because I don't know when his next autocross is, and it's wintertime now. All right, so that brings us to this, recommendations or general observations now that we have a little bit of data on these cars. If you're not autocrossing or tracking your car on a road course, it's probably pretty unlikely that you'll experience any real issues, at least in the short term. Nobody's put 30,000 miles on these cars in MK7 retrofit form yet, so can't speak to the long-term longevity. But the nice thing is, if it works for you, then the PCV valve is only a $60 part after the initial purchase of the TIG1 hose. Next up, 2015 and 2016 model year cars, they seem to be a little bit more likely to have issues, at least as a basic retrofit. I probably would not recommend doing that without willingness to add the Venturi as well, or just do something else. Get an AP valve or whatever you're supposed to have. Just know that you're probably at a little bit of a higher risk of it not working out. As far as street-driven big turbo cars go, that's been a kind of a happy little discovery. Nobody's really had issues yet. Several of the people who've switched have reported better idle quality, particularly those with, coming from aftermarket PCV plates. Also, don't have to dick around with emptying catch cans, which is nice. And I think number 3 is key. You need to be willing to add the Venturi. Fairly confident that maintaining a constant vacuum on the crankcase is the primary reason that Mark 8 GTIs and Rs just plain don't have widespread smoking problems, even in track and autocross situations. The simple fact is, if vacuum isn't constantly built up and depleted completely every time you go from gas to brake, there won't be any significant pressure differentials to drive oil pressure upwards, or oil and blow-by upwards in the first place. Also, data on the turbo inlet pipe and intakes causing issues is a little too inconsistent to draw any conclusions just yet. I still think that there might be something there, but I want to get some measurements on my car and on another guy who has a 2260 car. He was actually on one of the reports as well. He let me know he lives like right around the corner from me, so I'm looking forward to getting some data on a big turbo GTI locally. He currently has the car retrofitted as a basic retrofit, doesn't have any issues with it or anything, but yeah, be curious to see how the turbo inlet pipe vacuum differs. So that's about it for now. Appreciate everybody who's gone through with this. So now that we know a little bit better, those are my personal thoughts on everything. As always, modifying your car, I can't guarantee anything. Freaking Volkswagen owners like to modify every goddamn thing under the sun. And yeah, so there's a million variables at play. There's infinite number of different engine conditions and ways that things can fail and all kinds of stuff that can go undiagnosed. I think that there's a lot of engines that have some, very minor problems that maybe the PCVs can't compensate for, and putting on a PCV plate might mask the issues until they get far, far worse. Probably due to the sensitivity of the diaphragm, having to operate in probably a given range to effectively work. But I think the best shot with the Mark 8 valve as it is now is being willing to add the Venturi as well, just from the get-go. It works really well. It's super effective, and honestly, that's probably most of the magic in the Mark 8s themselves as far as the crankcase ventilation system goes. So till next time, take it easy. Keep up with the latest posts at www.datadrivenmqb.com. Like and subscribe to Data Driven MQB on YouTube, and follow Data Driven MQB on Facebook.